gaps in existing solutions are the lack of idea available, lack of idea available, and existing solutions focus on one aspect.
Our proposed solution is that we're making an Arduino-based sensor. We're using ECG sensor electrocardiogram, which senses the electrical pulses of your heart, and it reaches a cell. And if we are sending too many electrical signals or too less electrical signals, it will give a buzzer.
Components requires a PPG sensor, battery, connectors, wire, buzzer.
How this works is we have ECG sensors here. These are the electrodes of the ECG sensor. They will be connected to your body. They will send the electrical pulses and it will be read by an Arduino. If the electrical pulses is too high, we have a battery connected with a buzzer, and if the electrical pulses is too high, the buzzer will go off.
Now we'll be explaining about the parts. This is the Arduino, this is Arduino Uno, and these are the connecting pins. We are using 11 and 10, and we are using 5 volts and the other ground pins. This is the connection for ECG, and this would be connected for laptop. And coming to ECG, ECG has connectors from Arduino, and it also has a port for electrodes. These are the electrodes. These are the 3 electrodes. They are supposed to put in different places. What these electrodes do is they get electrical impulses from your heart and they give it to ECG. ECG converts those electrical symbols into binary format, which gets fed into Arduino. And from Arduino we get an integer value like 200 or 300, from which we can set a threshold. Seeing that threshold, if it's over the threshold, we get a buzzer. To support that, we have a battery. It's a 12-volt battery, and we also have a buzzer to notify the user if the threshold value crosses.
So along with the alert, we also get display. So this is an ECG graph, that is electrocardiogram graph. It is a visual representation of heart's electric activity over time. So it's basically a non-invasive test that measures the small electrical changes occurring in the cardiac muscles, the depolarization and repolarizations due to each heartbeat. So to perform an ECG, electrodes are placed on the patient's or the person's limbs, chest, which detect electrical pulses. A standard 12-lead ECG uses 10 electrodes to measure the heart electrical potential. A normal ECG graph displays several distinct waves and complexes. So to represent the graph, we have P, QRS and T waves. The P waves represent the electrical excitation of depolarization of atria, initiating the arterial contraction. QRS is a complex which represents the depolarization of ventricles, which is essential for the ventricles to contract and pump blood. And lastly, the T wave indicates the repolarization of ventricles, where they electrically reset and relax. Changes in the normal ECG pattern can indicate various cardiac abnormalities such as heart rhythm disturbances, inadequate coronary artery blood flow. So ECGs are used to access heart health, monitor medication effects, and check implanted cardiac devices.